Hi students, in this class we will learn about kinematics equations. In physics there is a branch called mechanics which deals with the motion of objects under the action of forces. Kinematics is a branch of this mechanics which deals with the motion of objects without reference to the application of forces. Therefore, how do you define kinematics? Kinematics is a branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. Since we are studying the motion of the objects, we are interested in its speed and velocity. Speed is the rate of, whenever I say rate of, it means divided by time, rate of distance. In this place distance, if I write distance covered in a particular direction, I can write this as velocity. Velocity is equal to distance covered in a particular direction is known as displacement. Therefore, displacement over time is known as velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. Vector quantity means it has got both magnitude and direction. Scalar quantity means it has got only magnitude and no direction. Speed is equal to distance by time. Speed is represented using the letter V. Velocity or speed is represented using the letter V. V is equal to S by T. Distance or displacement is represented using the letter S. Distance is always measured in meters. It is SI system of unit. Time in seconds. Therefore, speed will be having the unit meter per second in SI system. Another term which you come across while dealing with the motion of objects is acceleration. We know the speed and velocity. If there is a change in velocity, say the initial velocity be u and final velocity be v. The change in velocity will be final velocity minus initial velocity. If there is a change in velocity, then there is acceleration. Acceleration is the rate of change of velocity. What will be its unit? This is change in velocity. Velocity unit is meter per second. Divided by time unit is second. Meter per second by second is meter per second squared. Therefore, acceleration is having the unit meter per second squared. Acceleration is equal to change in velocity by time. A is equal to V minus U by T. Whenever there is a change in velocity, there is acceleration. What do you mean by uniform motion? Uniform motion is the motion which does not change. That in this case, the object travels with uniform speed. If the speed is uniform, it means that the velocity is not changing. The velocity is remaining constant. If the velocity is remaining constant, will there be acceleration? No, because acceleration is the rate of change of velocity. When there is no change in velocity, the acceleration will be 0. Here, uniform motion refers to the motion that does not change, and here the object travels with uniform speed. Velocity of the body remains constant as it covers equal distances in equal intervals of time. And when the velocity is remaining constant, the acceleration will be 0. Look at this diagram. Equal distances are covered in equal intervals of time in the case of uniform motion, whereas for non-uniform motion, unequal distances are covered in equal intervals of time. This is the time axis, and distance is shown here. For examples, from 0, 1, 2. For these two divisions, the distance is 2 meters. For next 2 seconds, 2 divisions, 2, 3, 4, 2 divisions, it is 2. Again, for the next 2, it is 2. Here, this is uniform. Whereas in the case of non-uniform motion, this will not be the same. For these two divisions, here it is 2, then it is 5, then 3, 4, etc. Remember, for uniform motion, the speed will be uniform. Uniform acceleration or constant acceleration is the type of motion in which the velocity of the object changes by an equal amount in equal intervals of time. Best example for uniform acceleration is that object in free fall in a uniform gravitational field. Acceleration A is equal to V minus U by T. Therefore, V minus U is equal to AT, or V is equal to U plus AT. This is the first equation of motion. V is equal to U plus AT. SUVAT equations. The SUVAT equations are kinematics equations in physics for motion under constant acceleration. SUVAT is an acronym from the variables. S is equal to displacement. U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time. Please note that the SUVAT only works with uniform acceleration. The first equation is V is equal to U plus AT. We learned speed is equal to distance divided by time. Therefore, distance is equal to speed into time. When we say average speed, if the initial velocity is u and the final velocity is v, the average will be u plus v by 2. Therefore, s is equal to u plus v by 2 into t. This s is the distance travelled by the object moving at an average speed. Now we have two equations in hand. One is v is equal to u plus at, and the other is s is equal to u plus v by 2 into t. Let us combine these two equations. We know v is equal to u plus at from the first equation of motion. Substitute that value of v in this place. Therefore, s becomes u plus, in the place of v you must write u plus at by 2 into t. That is 2u plus at by 2 into t. 2ut plus at squared by 2. From that you can write s is equal to ut plus half at squared. We know s is equal to u plus v by 2 into t. From this, what is the value of t? T is equal to 2s divided by u plus v. We also know v is equal to u plus at. Substitute this value of t in this expression. Then v becomes v is equal to u plus a into 2s by u plus v. This can be written as u into u plus v plus 2as divided by u plus v. When you remove this bracket, you can write as u squared plus uv plus 2as divided by u plus v. Now cross multiply like this. V into u plus v is equal to u squared plus uv plus 2as. When you remove this bracket, you can write as vu plus v squared is equal to u squared plus uv plus 2as. Bring it to one side and equate it to 0. From this expression, you can easily write v squared is equal to u squared plus 2as, because this plus vu and minus uv get cancelled. We have learned the SUVAT equations. The first one is V is equal to U plus AT. The quantity that is not used here is distance. The second, S is equal to U plus V by 2 into T. The quantity which is not used is acceleration. In the third, S is equal to ut plus half at squared equation, the quantity which is not used is final velocity. In this equation, v squared is equal to u squared plus 2as, we have not used the quantity time. In this class, we learn about kinematics. What is kinematics? It is the branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. Then we learned about speed, velocity and acceleration. Speed is the rate of distance, whereas velocity is the rate of displacement and acceleration is the rate of change of velocity. In acceleration, we discussed about zero acceleration and constant acceleration. Then we learned about uniform motion. In uniform motion, we understood that the object travels with uniform speed. Finally, we learned the equations of motion or SUVAT equations. The SUVAT equations are V is equal to U plus AT, S is equal to U plus V by 2 into T, S is equal to UT plus half AT squared, V squared is equal to U squared plus 2AS. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.